Hello, math humans. We're going to do 6.3. We're going to be doing more work with differential equations as the Pink Panther plays in the background. I think that's funny. Our objectives are that we're going to do more DE fun. So most of Chapter 6 has been about differential equations. So today we're just going to jump right in with some examples. So for our first example, I want to find the general solution of x squared plus 4 times y prime is equal to xy. I think that adds some drama to our math today. So I'm going to go ahead and rewrite this as x squared plus 4. I'm going to write it as dy over dx so I can separate my variables and then times xy. So as I cross multiply, okay, I'm going to get, remember I can't use an equals, I can use an arrow to show a progression of math. I don't want to write an untrue equality statement. So I have x squared plus 4 times dy is equal to, and I'm going to divide by y, and then I'm going to have x dx. I have to mathematically, technically leave something here so that I can have something to multiply by, okay? So then now I'm going to move the x squared plus 4, so I'm going to get 1 over y dy is equal to x over x squared plus 4 dx. Okay, that's called our separation of variables. Now I'm going to integrate both sides, and when I do, I'm going to get the natural log absolute value of y is equal to, on this one, I'm going to let my u equals x squared plus 4. My du is 2x dx, so the integral on this side becomes 1/2 the integral of 1 over u du. So this is the 1/2 natural log absolute value x squared plus 4 plus c. But in a differential equation, if the goal is to solve for y, I'm not done. So because these are both logs on both sides, okay, and I'm going to look at my problem a little bit. The plus c is the problem child. So I can't do the one-to-one property because I have a plus c. If the plus c wasn't there, I could have done my one-to-one property. So the next thing that I'm going to do is I'm going to move this half, and so I'm going to rewrite this as the natural log absolute value of y is the natural log square root of x squared plus 4 and then plus c. This is the properties of exponents that moves it to here. The absolute value can go away because x is squared, and so the value is always going to be positive, and then I have my square root. So now I'm going to go back to exponent form, so I'm going to do e to the natural log x squared plus 4 plus c is equal to y, okay? And if I have e raised to the natural log, and e raised to the c, I can rewrite this as e natural log square root x squared plus 4 times e to the c, because if the bases are same, you add the exponents. E to the c is just a constant, so we're just going to call that guy c, and then e to the natural log of this is going to become c e, and then I'm going to write the natural log of x squared plus 4. This math right here, I'm going to write y is equal to c, and then I have the square root of x squared plus 4. And then if I identified my work well, this is my general solution. So this is just one of those weird little properties of logarithms that are really handy to remember. Okay? All right, let's do our next example. Example number 2. I'm going to find the particular solution. So because I'm finding a particular solution, that means that they have to give me an initial condition for x y prime equals y minus 1, and x is going to be e and y is going to be 2. Okay, so anytime they're asking you to find a particular solution, they have to give you an initial condition. So I'm going to rewrite my differential equation. I'm going to write x dy dx is equal to y minus 1. Again, I'm going to cross multiply, so I'm going to leave this guy here. So I'm going to get x dy is y minus 1 dx. And then I'm going to move my things around, so I'm going to have 1 over y minus 1 dy is equal to 1 over x dx. Okay? So that's actually kind of polite. Now I'm going to integrate both sides. So on the left-hand side, this is just going to be 1 over u, and my du would be dy. So then this is just going to be the natural log absolute value, y minus 1, is equal to the natural log absolute value of x plus c. Okay, so sometimes if I'm solving for c, it's easier to do it now than it is to wait until the end of the problem. So I'm going to write that c is equal to the natural log of y minus 1 minus the natural log of x. So this is going to be the natural log of 2 minus 1 minus the natural log of e. Okay, the natural log of e is 1. And then this is 2 minus 1 is 1. The natural log of 1 is 0. And so c is going to equal a negative 1. Okay? So now what I can do is I'm going to go back and finish the problem. So I have y minus 1 is equal to the natural log absolute value of x minus 1. I'm going to go back to exponent form. So e to the natural log absolute value of x. And then technically this is going to be e negative 1, right, is equal to y minus 1. So now I can rewrite this. So e natural log of x is going to be x. E to the negative 1 is equal to y minus 1. So y is going to equal x over e plus 1. And this is my particular solution. Alrighty, I have one more example for us for today. So example number 3, helps if you turn your pen the right way, says find the particular solution that satisfies our differential equation of 2xy prime minus the natural log of x squared equals 0, and my initial condition is this. And this is the same thing as saying f of 1 is equal to 2. It's just another way of writing that information. So again, I'm going to start by rewriting y prime as dy dx, because I think it just makes the separation of variables a little bit easier. And then I'm going to take this to the other side, equals, and I'm going to manage the exponent while I move it, so I'm going to get 2 natural log x. Okay, so if you'll notice, my 2's are going to cancel, so I have a 2 on both sides. I need to cross multiply, so I'm going to get x dy is equal to the natural log of x dx, divide, so dy is equal to natural log of x over x dx. Okay, now I'm going to integrate both sides. On the left-hand side, I get y. If my u is the natural log of x, my du is 1 over x dx. So I have everything I need. So this becomes u squared over 2 plus c. So the right-hand side is going to be the natural log of x squared over 2 plus c. Well, now I need to solve for c. So I'm going to substitute in my initial condition. So I'm going to write 2 is equal to the natural log of 1 squared over 2 plus c. The natural log of 1 is 0, therefore this is 0. So I get c is equal to 2. And then now all I have to do is write my particular solution. So my particular solution is going to be y equals the natural log of x quantity squared over 2 plus 2. And then that's it. So that was nice and polite. All right, that's it for today. I will see you soon.